Hello. How is it going? Hi, folks. Let's wait couple of more minutes for everyone to join. I see people are rolling in from Twitch. Amazing. We are on time. How's the day going so far? I'd love to know that in the chat. I'm also setting things up from my side because today is the last day of our Kubernetes workshop. I'm so excited. I'm so glad finally we are done, right? Hi, Crypto. Welcome back. Hi, Blaze Killer. Your day is going lovely. That is amazing. That is amazing. Hello. Awesome. Let's have a few more folks joining in. All right, if you are wondering why my background has changed, this is not a virtual background. I am in Vijayawada. I'm not at my home. I'm here to coach an MLH member event. I'm excited for that. It is starting tomorrow. So yeah, I'll be doing the final day from here. Hopefully the hotel Wi-Fi survives. I am getting pings here, warnings here and there. Let me know if I stutter or if you miss anything. Please let me know in the chat. Looks good so far. I did not see any complaints, but please let me know if anything like that happens. Alrighty. Okay, we have good amount of folks joining in. What we're going to do today? More like, what are you going to do today? We have been doing quite a lot of editing and creating new files and playing with terminals and stuff. And in the last part, we succeeded in creating and deploying our own application to Kubernetes. That was fun. And today we are not going to create new things. We are just going to play with Kubernetes. I'm going to show you the real power and why Kubernetes is so often used in the cloud native space. Not everywhere, but where it is used, it's super powerful. And why is that? So sadly, I don't have a lot of slides, only one slide for you today. Not a lot. We're going to do a quick recall of what we did in the last stream. What is pod, the components of Kubernetes, pod, node, and cluster, how they work. YAML is always a headache, but we have to survive with it. YAML is pretty amazing if you learn it right. So we are going to just do a quick recap on YAML syntax and just go over the configuration file we made yesterday. That was only 2 files. So, but what we're building today is going to be pretty much fun. We will test the power of Kubernetes. I'll start by creating a self-healing. I'll show you how self-healing actually works in Kubernetes. And if time allows, we'll try a couple of more stuff. We can try rolling updates, which, is a pretty cool stuff if time allows. So we'll definitely do self-healing today. But if time allows, I am going to also show you how rolling update works. And by rolling update, I mean, how the features in your phone, when you get them without even realizing, like new emojis in your keyboard, you did not even update them, but you got them. And new features on Instagram, new features on WhatsApp and stuff like that without you even realizing. At the same time, sometimes it happens like your friend got it and then you got it. It's not at the same time. So that's rolling update. And we are going to do that live with our application, the application that I made in day 1. I'm going to try to put self-healing in that. I'm going to destroy it and see as Kubernetes heals my project back to the server. And if time allows, we are going to do a rolling update of our project. That's it for slides for now. Awesome. I'm so excited that you are excited. If you were following along with us, which is great, feel free to follow along with me. There is only one file. I promise we are creating new today. Only one file. There's just one single YAML file. Awesome. You know how to destroy a server already? We'll get going in that. Hi, Himanshu. How is the day going? We are about to get started with our final day of Kubernetes. Today, we'll just play with our Kubernetes server that we created in the last stream. And I'm going to show you the powers, some of the popular features of Kubernetes. So if you missed anything, everything from the last streams are there in the resources down here in my GitHub repository. Feel free to take a look, copy the files. The files that I'm using today are in this, so these are the exact same files if you want to save your time or want to follow along. If not, feel free to watch it. This is You can always come back to the resources and the stream to try it out. I'll be happy to help you with that. Awesome. I don't have an extra screen, and I now realize how handy it is when you have an extra screen. But never mind, I'm going to stop and I'm going to again start sharing. Let's see, where is my, there we go, GSW December. Whoa, that's weird. Oh yeah, there you go. Hi Ashish, hello, how is it going? Oh, okay, yeah, there is my stream. Yeah. Awesome. So we are going to catch up from last part. Let's see what we missed out or what we did in the last part. So in the part one, we created our own file, or I'm assuming you already have a file. So our concern is not the project. Whatever it's created is fine, or you can use what I created. It was simple index HTML file, a simple web application deployed, which runs on a Node.js server. So a simple front end and back end, a simple web app. We learned how to containerize it using Docker. We learned how to push the Docker file to Docker Hub and then pull it down, just like GitHub repository, you push and pull. But here it is a container. So it is independent of OS, no installation required. I don't need anything else. In part two, we run that container into the Kubernetes cluster and then expose that port to our local host using node port. Hi Taukik, you're not late. You're not late at all. We're just recapping the part one and part two. So part one, we learned how to containerize. Part two, we learned how to run Kubernetes on the containers. We exposed the port using node port to our local host system. We opened the local host and it worked just fine. Today we are going to just play around with that. So not a lot of things, couple of one or two, maybe three more new commands and one new YAML file we will be requiring for to test the power of Kubernetes. So you did not miss on anything. And feel free to ask even if you feel like you missed anything. So today I'm not going to open, I'm just going to keep my VS code open and I'm going to make sure everything is just open here. So I'm going to, whoops, don't need this. Let me open multiple terminals here, new terminal. Let me, editor area. Yeah, this is fine. Oh yeah, this is good. Most of our work is in terminal today. Yeah. Hi, Gaming with Cyrus. How is it going? I was literally procrastinated to learn Kubernetes, but you made it easy. I'm so glad you're finding it fun now. Uh, Trust me, I've been in your place, and I do it all the time. Procrastination. When you're doing it alone, it's actually really boring. Not just Kubernetes, anything. And if you're doing it in team, in a community, in live streams, it is so much fun to do it along. So feel free to like make new friends. You're already I'm your friend. There's Ashish, there is crypto, there is gaming. Feel free to just talk to each other and see if you can play with each other's containers, dockerize and containerize it, or maybe just run it on Kubernetes server. So it's much more fun when you do it together. Today most of it is in the terminal. I have my Docker desktop running in the background. Let me just see Docker PS. So I have my Kubernetes clusters running from yesterday. How? kubectl, get nodes. There's one node which says Docker desktop. It is ready and it's the control plane node. So control plane node is the master node which control all the worker nodes. And the worker nodes has pods. Pod is just basically a wrapper around container, right? I'm gonna rewatch this series after Global Hack Week. Awesome. Feel free to do that. Hi Miraz, how is it going? Cool. So pretty simple. You can see the hierarchy that at the bottom is the container, which is running our application that we containerized. Around the wrapper is the pod, which has the IP address and stuff for Kubernetes to communicate. Each couple of pods are run in a worker node. All worker nodes are controlled by the control plane node. And in this case, all I can see is control plane node because I have nothing else running. Let me know if this font size is visible enough for you, or may let me do this. Yep, even better. If this is not, I can zoom in. Hi, Gaming with Cyrus. You're new to Kubernetes. Awesome. Everyone here is new to Kubernetes, including myself. I'm so happy for you to join us. Uh, if you want to know what is Kubernetes, it's container orchestration. Uh, that's a lot of jargon. In simple words, it does the work that I don't want to do in the server, in the cloud. So things that you don't see while new applications are being made, and how social media works and how those big infrastructures work automatically with less workforce is done by Kubernetes. A good example is how social media apps are always online. They never go down even after failures. So if there's a failure in India, it will still work in the States, or it will work in Brazil. Why? There are different servers, but who is managing them? There's no person there. Another example is Discord. Yeah, Discord is a great example. If you go to the Discord status on the website, you will see uh, the uptime, and it's mostly 99% up. And once it goes down, it quickly comes back up. uh, Most of that is handled by Kubernetes. Worst case scenario, when we see like tweets like Discord is down and it's not coming back up, that is when there's like a Kubernetes failure, or there's an orchestration failure. Another example is how you get features on your phone without you even realizing, and sometimes you get those features like your friend gets it first, and then you get it, and even though all of you have the same version, like updates on WhatsApp, like how the sticker feature came. I did not update my WhatsApp, it just came, and then next week in my friend's phone, and today I got a feature of avatars in WhatsApp. So it just came, and it's called rolling update. We heard this, we'll be rolling out the updates to your phones. You hear that? So that is uh very basic example of what Kubernetes can do without human interaction. I can do it manually, but for tens and thousands of devices, Kubernetes can do it automatically. Few minutes ago, I don't know Kubernetes. After explaining, yeah, thank you so much. But it is simple as that. It can do lot more than that. But these are some of the popular features of Kubernetes. We don't know that it's always there. So back to this kubectl get nodes. I have one node, kubectl get pods. It's a simple command. Kubectl is kube control. Let me know how you pronounce it. I say it kubectl. It's called, like, I call it cube. So let me write here. I call it cube ctl. Some people call it cube cuttle, and some people pronounce it uh, cube control. Feel free to call it whatever you like. But I call it kubectl. It stands for kube control. This command interacts with the control plane node, the one which we saw earlier. This one, it interacts with this, and this interacts with all the worker nodes, and that worker nodes interact with the uh, all the pods. So it's kind of like the principal of my college, and principal talks to all the head of departments, just one thing, and then it's a chain of command. Principal doesn't have to worry. uh, the head of departments tells to the teachers of their department, and the teachers tell to the student. So if I tell, I'm the user, I'm telling my principal that, hey, let's start a new website. uh, so principal has to listen to that. That's the control plane node. And principal tells to the head of departments that, hey, we need to start a new website. And then head of department tells to the teachers, and then to the students, which start working on it, and stuff like that. Instead of website, we can say like a new class or stuff like that. But you get the analogy of the hierarchy of how it works, that I only have to tell one object, and it passes on the commands to all, and it handles the work for me. So kubectl is the one that is doing all the work for me. So I can say, hey, kubectl, get me all the pods. So I just ask for nodes, all the pods. So I have pods running. Oops. Okay. So this is, let me just delete this uh, because I want to start afresh for this. See. delete. All right, it should start deleting now. Yep. Let's start afresh today. Could be any principle. I'm not targeting any principle. So, no, oops, not deploy. Get pods. kubectl get pods. Oops. Oh, it's still terminating. Okay, it takes time to delete. So you can see the status is terminating. It take a couple of minutes. So kubectl get pods asks tells me what are the pods that are running right now. Yesterday we had just one pod. Today we are going to actually achieve this. I'm going to tell you why and how. Is it deleted? I hope it is. Gone. All gone. Awesome. No pods right now. If I go to my local host 30,000, nope, it's not working right now. Obviously, you can't see because I have not shared that screen, but that's all right. That's okay. Not a problem. Uh, we are going to achieve today. The first thing that I showed in the slide was, but before we do that, let's again do a bit of revision on YAML. Actually, we'll do that alongside. So, a couple of powers of Kubernetes. One is self-healing, the most important. Self-healing is like you have a pod running, it goes down, then what? Like if a server goes down, if a server like this one, let's just say, so I'm using this terminal below, if you can see. So I have my file on the right hand side and I'm going to run it using node, not Kubernetes, basic node app.js. A server is running fine. If I open localhost, it will open it. All right, if it goes down, what happens? So I'm going to do control C. Now it won't work. I have to manually run it again. It is fine, but 12 a.m. at night, I'm sleeping, and people in the West, I'm in India, and people who are in Eastern time zone want to look at my website. They have to wait till I am back up again, and then I have to manually run it again, and then they can see my website. That is not a good experience. So self-healing is one of the properties of Kubernetes, where when it detects pod has failed, it will restart it. Simple as that. They're going to do that. So in order to unlock the power of Kubernetes, where self-healing and other power comes, we'll create one new file today. It's called deployment. I'm going to go here and call it whatever you want. I'll call it deploy.yaml. The deployment file contains the instruction to tell the Kubernetes how things are deployed. Simple as that. So there's a deployment controller. If I just Google it, Kubernetes deployment, you will get even more elaboration that there is a controller that is looking after our nodes. So it's like, in terms of academics, let's say it's like uh, who's there who oversees all apart from principal, the director or the dean. The dean is the one who oversees all the head of departments. uh, its job is to make sure everything's running smoothly. If director or principal gives the command, dean makes sure whatever the command is given is being followed. So that's what deployment controller does. It keeps a watch on the pods and looks at it. If anything is changed, it will make sure that you know the actual state comes back to desired state. So I'll tell you what actual state and desired state is, but before that, a quick revision on YAML. YAML stands for YAML Lint Markup Language. It's very popular. What do you call it? Like uh, it's not a markup language. It's more of it's like a JSON. It's a configuration language. You can create configurations for anything that you want. If you know JavaScript, it's like a JSON file, JavaScript object notation. So on the left there is a value, on the right there is the key. Sorry, on the left there's a key, on the right is the value, key value pair. So I tell you the key, and this is its answer. So it's simple as that. If we look at the old YAML files, pod.yaml describes how a pod should be. That's what YAML is. It's a recipe book. It tells this is what I'm about to define, and this is how it looks like. So on the left, you see the API version of Kubernetes is 1. What kind of configuration is this? It's a pod configuration. Metadata, which is unique to the pod, the personal details like my name, my email address is my metadata. So here the name is first pod. The label I'm giving is it's an event we are using called the event is the key and the value is GSW. These are all I can put it anything I want. And next we have the specification. The specification of what? Of containers. Okay, but what kind of specification I'm giving? Then I put and I name list those. So list starts with a hyphen. You'll see this yellow line that's warning. I'll tell you why it is, but not right now. So a list of contain. I'm about to list the specification of containers, which is hyphen. The first one, the first item in the list is name. I call it anything. I call it node. The image I'm using, be very careful with that. The image I'm using here is GSW version 1.0. Let me show you Docker images. So I have, here you go. Yeah, GSW version 1.0 right here, which we created in day one, in part one. So I'm using that image. That is the image which will create my container. All right. The ports I'm using to expose my application. What ports? The container port, which is from the inside, which will be exposed, should be 8080. My application has 8080. Inside the container is also 8080. Outside, it is something different. Now, this is how my pod was defined. How do I connect this pod to the outside world? I have to use an API service. The service to communicate with my pod and Kubernetes and my browser. So I use something called where is that service.yaml. Like to put a split screen. Service.yaml, same as before, same as a pod.yaml. The first half, if you see, defines what we are about to what is this configuration, and the specification defines what exactly it is. So we are about to define a service, again a name, and the specification of the service. So we are using node port because node port we are deploying this cluster locally and not on the cloud. So we are using node port. This is by default in Kubernetes. If you go to documentation, we use node port by default, and I'm defining the ports. So the port I'm using is 8080 inside my node port. Protocol TCP/IP standard protocol. Target port is the one on the left. This container port is my target port here. So that these two can talk to each other. Node port is the one that is facing towards the browser. So localhost 30,000 is where I will see my output, not localhost 8080. That these are internal ports. Selector is important. So selector is another controller which tells the service which pod are we looking at, because none of these has any relation with the pod. There can be multiple pod configuration files. I can have one for Saturday, one for Sunday, one for this image, one for Python image. How do I tell this service to look for global hack week? So I add a selector. Think of its selector as a filter. It will filter all the pods. What is the filter? The event should be GSW. So this service will look for all the pods which has a label of key value called event GSW. I can have multiple events. That's why one key can have multiple. So I can have event some hackathon, right? In another pod. So it will exactly look for a configuration which has event called GSW, and then it will expose the ports of those pod to my browser. Don't believe me? Let me run it. How do you apply this configuration? I have nothing running right now. So kubectl get vc. Okay, let me delete this. I have this thing running. Kubectl delete. SVC stands for service. All right. So I don't have pods running. I don't have service running. Oops. kubectl get. Yep. I don't have service running. Default service of Kubernetes, the main cluster, and no pods. All right. First, I start a pod. Kubectl apply. We apply a configuration file. File is f. It's not force. It's file. I'm applying a file. If I don't use this, it will give me an error. Yeah, it does not know what is it. So apply a file. Pod.yaml. Pod has been created. Let me show you. Let me close this. Kubectl get pods. Oh, kubectl get pods. We have one pod running called first pod because that is the name. Let's not touch. Oops. Let's not. Okay, first pod. So it is running one by one. Only one pod is running and it is ready. Age is 20 seconds. Now it will be older, 36 seconds. Okay, you know what? Let's use the bottom one for cubes for get pods because it's wider. I can see longer output. Kubectl get pods. And let's run all the app apply on the right hand side. Okay, first pod is running, but still I won't be able to see because there is no service connecting my container pod to my ports. So I'm going to apply the service now. Kubectl apply, same as the name of my service. It's called service local. I called it local because for cloud, there are slight changes in the YAML file. So feel free to call it service.yaml also. Service.local. Let's expand this a little bit. And before I do that, okay, yeah, that's fine. Kubectl get service and the bottom. Only one service is running right now. Enter. Created. It says yes, it is created. It's called node pod. The cluster IP, that is the internal cluster. This IP address is used by the control plane node to communicate. So external port is 30,000. Let me go ahead and check out 30,000 in mine. Localhost 30,000. Yep, it works. Can I share my screen? Absolutely, I can. Where is it? There you go. It runs just fine. Oh, you can see. Yeah, there you go. It's running just fine. This is what we did yesterday. Now let's go back to create a deployment file. So it was empty. We did not do anything because now we will. Deployment, most of it is same. Okay. Yeah, there you go. Deployment, it's empty right now. Most of the stuff, the basic stuff of, when you start to define a container or stuff is same. I'm going to start again with API version of Kubernetes I'm using is called V1. There's something wrong. Untracked. Oh, that's fine. That's fine. Kind. Okay. For reference, let's use this, or let's keep this here. Look at the service.yaml for good reference. So we'll just inspire from service.yaml. Oops, what a mess. Kind was here. It's a deployment. Now, one thing to keep in mind is when you're defining the key, it's camel case. That is the first word, first letter is small. Second word, first letter is uppercase. When you're defining the value, it's called camel. It's called Pascal case. Pascal case. So first letter of each word is uppercase. That's why, because of that, we were facing some issues yesterday. So that's one thing to keep in mind. So this is camel case. Yeah, that's why it's uppercase deployment. Or is it deployments? No, it's deployment. That's fine. So deployment tells, the kind section tells what type of object it is. Think of all pod, node, deployment, service as objects of Kubernetes. What kind of object is told by the kind key. Metadata to identify our configuration. It's optional but highly recommended when you want some relation. So I'm going to call it BAW deploy, only the name, nothing else I need. Specifications. So let's add here. Now, okay, I need to keep up with the chats. Awesome, no new questions. Specifications. uh, remember I want to add self-healing properties. Okay, so if I go to, let me share my screen. Let me share my whole screen for now. All right. So if I go and write Kubernetes deployment, or let's just Kubernetes deployment, I'm about to do what is exactly mentioned in this first page. Like, feel free to go to deploy the documentation and take a look at what's happening around. So I want to have that self. So we'll be trying out a couple of these things. So one is like deploying a rollout. Yes. We want self healing. So if I'm starting with self healing. So uh, I'm going to look through this. See, for the first of the few things are same. Labels is optional, but I can add that. In spec, the first thing is replicas here. Now replicas tells how many duplicate pods we want. So how many replicas of the pod we want. Simple as that. So when we right now applied the configuration file, it just created one pod called first pod. This will create three. Then we have something called a selector, match labels, something, template, metadata, and whatnot. Let's go through this one by one. All right. So pulling my VS Code back and pulling it up back again, following what was said in that. So we have specification, replicas. Now remember, if I do kubectl get pods, I right now have only one pod here. I'm not confident. When this pod goes down, remember the whole website goes down. So I want three replicas just in case. So even if one pod goes, let's see what happens. All right. Replicas is three. Next we will, what was next? That next was something called a selector. So selector, what is a selector? So selector is again basically a filter which tells the deployment file or deployment controller what to do next. So I tell the selector, hey selector, apply these to the pods who match the labels. Who match the labels of what? The label was event GHW. Oops, that's it. So match labels, this thing tells the deployment controller which pod to manage. There can be lots of pods. Manage the pod whose labels are GHW. Then we have template. That is standard for, I guess this is there for, okay, this is not there in pod.yaml. Okay, it's not. The template is, if you observe, template is not inside the selector, but it is inside the specification. So I'm about to tell that follow this template when you're creating new pods, because I don't want all the pods. So every pod will be given some unique name, but it's going to be like weird, randomly generated letters. I want to follow a common suffix before you create new pods. So create a template of when you create new pods. Use this metadata called labels and add this label GSW. This is important because you want to track all the pods who have the label of GSW. So I'm going to say adds this label to new pods, helps in tracking them. Since my self-healing property should only be for GHW pods, I want to make sure when new pods are being created, they should also have GHW label. All right, this is done. But again, they should also have some specification of the when you're creating new pods, what are those new pods? So those new pods are containers. Those new pods are containers. They have the following properties: the name, not first pod at this point. It's let's call it GHW pod, or yeah, GHW pod. Yeah, or if you have any nice name, let me know. They have the following ports. I want to expose all the every pod that is there should be exposed at 8080. So container port inside internally, I want them to be exposed to 8080, right? But what pod are we talking? So don't forget the image. The image is Ashwin exe/GAW version 1.0. This should be good. Let's go again one more time. This part defines my container. This part till template defines my pod, the wrapper. This is the wrapper. This whole thing is wrapper plus container. And this whole thing up to metadata defines my deployment. Make sense? Any new questions? No. Awesome. One more time. From line 15 to 19 is my container information. If you see, if you just stop watching at everything else, this is the information of my container. If I go to till template, this is the information of my wrapper. Each pod will look like this. Every new pod that is created will look from here to here. And above that will be handled by my deployment controller, the dean, who will make sure, like, who will look into all of this from starting to end. So you see that nest. This should work so far. So what I'm going to do is go back here and here. So kubectl get pods. I have one pod running. If I do kubectl get pod with a -- watch, you will see I won't have my prompt again. That means it's constantly running now. Now the bottom terminal will look for changes. So every time something is changed in pods, it will update down. So we'll keep an eye on there while I apply my new configuration. How do I apply? kubectl apply -f deploy.yaml. Same as that. This should create 3 pods whose name should start with GHW or GHW pod, I guess. One of the two, if I'm correct. Okay, this is the label. So it should start with the name of GHW pod, followed by some random number just to make them unique. It cannot be GHW, GHW, GHW. Each pod is unique. If I do that, hit enter. Okay, we got some error. Namespace, API version, kind. Okay, I guess I have to put this first. Oh. Namespace from deploy, no matches kind deployment. DPLOYMENT. Is my spelling correct? Yes, it is. Oh, interesting. Yes. So if I go back to the documentation, for deployment, we don't use version 1, we use apps/version 1. This is where the deployment is stored. It's in the documentation and it's by default for some reason. Even I'm surprised. What is there? Something is wrong. I made some typo. There's an unknown field called under the specification, template, metadata, labels. Is there something wrong with labels? Let's look at that. Looks good to me. Okay, see, metadata. It's metadata. Yeah, typos like that can really take out. So if you just read the error carefully, it saves me so much time. I don't have to go through all of this. Usually the error will be at the last line because it goes from top to bottom. So it scans, and where the error is there, it just stops there and shows you in the last line. That's the trick I follow. Let's try it again. Another error. Replicast specification. Oh, it's replicas. Wow, so many errors. What is the stream, Ashwin? There you go. Whoa, what is happening? You see, it did not start right away. First, it created 5 pods with pending status, creating some of them. 3 of them are running right now, not all of them. If I run kubectl get pods on top, 3 GHW pods are running, 1 first pod. It's still trying to create, I guess. Oh, okay. We created 3. Awesome. We created 3 pods. Awesome. We are past the first checkpoint, but there's one more pod, first pod. Why is that there? There should be 3, right? So this first pod, because we manually run it, it does not comes under the deployment controller. Deployment does not know it. So it just runs on its own. Okay. You're late. That's fine, Bishnuk. The stream is recorded. All the resources I'll put it in the README. Quick recap. We are playing with Kubernetes today. We are not building something new. I already deployed my application in Kubernetes. Now I'm trying to make it indestructible by enabling or turning on the self-healing property of Kubernetes. I just did that. Let me show you. So these 3 are the servers or the containers running, and these are running under deployment. So if I do kubectl get deployment, see, there's a deployment called ghw deploy, which we named it here. 3 by 3 are ready. All 3 are up to date. All 3 are available. And there you go. Now let's try to do some action. All right. I'm going to destroy one of those pods. What's going to happen? Let's see. Copy the name. You know how to delete a pod. kubectl delete pod name. Notice what happens. All right. At the bottom, notice what happens. And also at the top, if I am fast enough to do a kubectl get pod. Oops. Oh, I think I did not copy the name right. kubectl delete. Oh, pod. Forgot to name pod. Deleted. It says, look at the bottom. It's terminating. Then it's pending, container creating, and running. It deleted a pod. My deployment controller saw there should have been 3 pods, but now there were 2. The desired state I said is 3. The current state was 2. It said, no, that's not right. That's not cool. Let's start a new one. So it started. Let me show you. kubectl get pods. I still have 3 pods. But now, if you see, the pod which ends with 4GDWK is not there. It is replaced by a new pod. The other 2 are there. You see that? If I go to localhost right now, let me see, is not service running? kubectl get a service. Yeah, if I go to localhost right now, my website will run. Let me show you. Localhost 30,000. There you go, it's running. Even if I delete one pod, let me see if this works. So let me delete just one pod, all right? At the bottom, I'm going to, no, let's not delete at the bottom. Let's just keep it watching. So I'm going to delete one pod. Which one should we delete? This. Oh, let's delete this one. kubectl delete pod. Yes. I'm going to refresh on the left. The website is not going down. It's still up. Remember how yesterday, when I deleted the first pod, the website went down? It won't, because the moment it sees terminating, you see, it goes to pending, and then there's a new container up and running. So my website will never go down. Even if all 3 are down, couple of seconds later, it will create 3 new pods. That is the power of self-healing. What happens to kubectl get pods to the first pod? What happens to that? The first pod. I did not put the self-healing property to the first pod. So if I do kubectl delete pod, first pod, deleted, I'm gonna watch for it. You see it's terminating the first pod, the 3 are running just fine. It, in theory, should not come back because it is not under the deployment controller. It is not handled by deployment controller. I manually deployed it using apply pod.yaml. I did not tell that deploy YAML to create pods for me. I created that pod. So I'm gonna wait for it to delete. Done. Terminated. See, now there are only 3. Even if I open Docker desktop, I'll only see 3. Oh, You can see my screen, right? Let me show you. You can see 3 pods. So that is the power of self-healing. Now, yeah, that was simple as that. Wait, let me see. Do I have any questions? Yep, you got it. Awesome. Where is my window? Here is my window. Yep, we are back. That is the power of self-healing. No matter what I do, let me just delete this one again. Kubectl, delete, pods, this one. Now delete, and then it's going to see, oh, it's missing. It's gonna create a new container with a new ID, and it's gonna start running it. You know what? I don't like. I like total destruction. I like creating mayhem, and I'm going to delete all of them. So there's a way to delete all that. I'm just gonna wait for my terminal to finish. That's a quick reminder for hydration. Stay hydrated, you all. We're already halfway. It's nice. You're on time. Actually, we can try a couple of new stuff. Okay, kubectl delete all pods. This will delete all pods. And to be frank, if I am fast enough, if I immediately refresh my page like within seconds after deleting, my website will go down and then will come back up. It's too fast for me to do it right here. Maybe not. But if you look at the bottom terminal, all 3 deleted, and then all 3 are running again. These are new containers, not the same ones. All 3 have new IDs. Even if you take a screenshot. Oh, you're not seeing my screen all this time. Oh my god. I'm so sorry. Let me just start over. What was the last thing that you see? Okay, you did not see the deleting all the pods. All right, fine. Let me just do that again for you. I'm gonna wait for my terminal to clear it up. It takes time to delete those pods because of Docker dev stuff, I guess. Yeah. Clean my terminal. Kubectl get pods. 3 pods are running. Kubectl delete all pods. Immediately, I'm going to do a get pod. Okay. See, it's terminating. Now, if I do it again, there are 3 running already, and it's terminating old pods, running new pods. The IDs are different. It's not updating them. It's not restarting the same pods. The moment that pod is filled, it's removed. It's starting a new instance, a fresh instance. That's why I use watch. It's easy. You don't have to run the command again and again. Awesome. Oh, okay. Yep. There you go. I hope I could. Can't I move myself to the right? That's fine. You can see it's terminating old pods, and only 3 pods are running again, but these are new. That's the beauty of it. That's the beauty of self-healing. It always works. Now let's try something else. Let's try scaling up and scaling down. That's so easy. It's such a powerful feature. Okay, before scaling up and scaling down, let's figure out what is this yellow bar is. So I installed something called a Kubernetes extension, which is very handy. You should all do it. So in VS Code, and it started giving me this weird yellow outline. And if I highlight on this, it says 1 or more containers do not have resource limits. This could starve the process. What is that? So it means I have not mentioned the limit of the resources that I can use. And this could cause problems when there are more containers. Basically, I should be very specific in how much CPU and memory I want to give to my containers. I can be, so let me show you the example. So I can add resources. That's what it wanted. And each resources has some limits. And I'm going to tell the CPU, let's give it 1 CPU. I'm going to give my 1 CPU, and I'm going to give it a memory of 500 MB of my PC. That's how you write it. You see the warning is gone. And if I run it now, something weird is going to happen. So, okay, this is still up. Let this be. Kubectl apply -f deployment. Oh, sorry, deploy dot YAML. Once I do this, deployment configured. Okay, there is creating new containers and deleting old ones. Remember, I put a 3 replicas. All right. Let's see what happens if I do kubectl get pods. Okay, 3 are still running. This is fine. Interesting. That's a good thing actually. Is it terminating any old ones? No. Oh, that's fine. Now, here's the thing. If now let's try scaling up now. Now I've been precise as how much CPU I want. It won't consume more than I should. So it won't slow down my system. It will only consume maximum of 500 MB from my system. Next up, let's scale up. Let's see. Let's say there's a lot of lot of traffic coming to my website, and I want to scale up my website. So I want more pods. In case 2 goes down, there is always 4 more and stuff like that. So let's scale it to 5. You want 6 or 10? 10 is like disaster. Like it's very hard to track. Let's do 5. Let's do 5. So let's make 5 replicas now. Now remember, I'm only changing the number here. I don't have to delete all pods, create new pods, tell which pods to create. Label is already there. Deployment is doing my work for me. I only have to change the number. If I apply it again, right now, 3 pods are running. I'm going to apply, and it should start 5 pods now. Delete all pods, start 5. So I'm going to apply this. Wait for a couple of seconds. Hi Shubham, how's it going? Thanks for joining us. If you missed something, this thing is recording and all the resources are there in my GitHub repository. If you have joined from YouTube, so it's in the description. Feel free to catch up with that. Let me do get pods again. 5, so 2 are still pending, but 5 are up. 5 are there. Deployment saw that they were supposed to be 5. The desired state was 5. The current state is 3. So it's going to scale up to 5. How? If you see the number, it has not stopped the old containers. I can see the same IDs. It has started 2 new containers, but they're not starting. For some reason, they're not starting, which is weird. If I do a watch, they should have started by now. Why they're not starting is because I have limited the memory. And that is why I removed this line. So if I just remove it, it will use as much as it can, which is not a good practice. It will give me a warning. But for now, I don't know how much memory is required for 5 pods. So I'm just going to comment it or just remove it from screen. I'm going to ignore the warning, but it should work just fine. So if I apply it again, you see, it's creating, terminating old ones. As long as there are 5, I am good. So get pods, still terminating old ones, still terminating old ones. It'll take some time. So I'm deploying container on cloud platform. No, I'm deploying it locally using node port on my local host, because I want all of you to follow along or make it easy to follow along. And not everyone might have access to cloud credits because you can't use it for free in most clouds. So you can do that. AWS or GCP, which is more user friendly. I couldn't get my pods running using AWS, so I used GCP, but that used inbuilt deployment files. That is all right. All cloud services have their own way of deployments. I used Linode, which also provides me with the deployment configuration. All I have to do is just paste it in my system and it works. But it's important you realize what's happening so I can make changes accordingly. Let me run this again. 5 pods only. All of them are running one by one. So I just remove the resource limit. That's all right. For production level, we can put a resource. This helps in managing cost. But for now, I was able to scale up. I can also scale down again. If I put that 3, I'm going to delete extra pods. Let me do that. And it's going to come back to 3. That is scaling down. How cool is that? Just change a number and you're scaling up and down. 2 days ago, it was such a hard concept just to understand. And now we are doing it right now. It's terminating two of the out of 5 pods. You can see that 3 are running. In a couple of seconds, those two terminating will be deleted from the list. Let's watch it. Terminating. And I know why the title is Global Hack Week. That's a really good question. Uh, Global Hack Week is a celebration of development and hackers. So it's a week-long event where we hack globally. By hack, we mean develop. So hacking and development is used hand in hand. So this is a week-long event by MLH. We do every other month. We have lots of activities if you're interested in machine learning, blockchain, this is cloud, Linux, Git, or just fun mini games and mini events. This is a week-long event that you can just enjoy to learn new technology, maybe to have fun, to earn stickers. So if you want to know more, if you're new here, just go to ghw.mlh.io. You should be able to see that. So I'm assuming you're gonna deploy container and try to hack. If I'm wrong, that's exactly what I'm doing right now. Again, the word hack and development goes hand in hand. So I just deployed a container, and in today's part, we are playing with this. By play, I want to show the power of Kubernetes. So once again, if you feel like what is hack exactly, in tech space, in tech communities, we use it for development, but there's a whole different domain of ethical hacking. We're not doing that. But if I go here, you can see it's terminated. kubectl get pods back to 3 now. Yes, we just scaled up and scaled down with a single number. That's so awesome. I can put it 10 and it can go like haywire with 10 replicas. That is like crazy. I don't want to do that. I mean, you can do that, but not really. It's a big headache. All right. If you are able to follow till now, shall we go ahead and try one more feature? Like this is a lot of feature right now. We did self healing. We did scale up and scale down, and we can do one more, I guess. Yeah, we have time. So let's try one of my favorite features, that is rolling updates. This is gonna take a bit more addition, but I promise this is the last thing you'll be learning. No new files. Congratulations, no more new files. We are only going to make changes in deployment, because when we are dealing with rolling updates, we are dealing with deployments. So I want to give a new deployment. The concept of rolling updates goes like this. You don't let the product go down while the update is happening, right? If I had to change a feature of Twitch here, let's say new stickers or follower button, we have subscribe button, let's say we have a add friend button or stuff like that. I don't want the Twitch streaming function to go down while that feature is being added, right? We have already seen if one pod goes down, there are two still running, so my website will not go down. So if I update one of the pods by bringing it down, two pods are still running. My application is working. One of the pod updates. Then second pod updates while the other two are working. Then third pod updates. One by one, I'm updating my pod. You won't see the change because the old pod gets updated to the new pod, and in one of those pod is one of your local host is running. So you never realize when it goes down. If it goes down, your local host is managed by some other pod. So that's how rolling update works. You never realize it, but it happens pod by pod. Just like how we just deleted our pods, the deployment controller started it one by one. We're going to apply updates. So just like how we scaled it one by one, now we're going to apply update one by one. Interesting. I know hack concept. I'm Azure security engineer. Was looking for any tech live channel. Your content popped up. That's so awesome. I'm not familiar with the actual concept of hacking, but Azure is a pretty cool technology. I think there are credits for Azure if you want to deploy your cluster to Azure service. So forgot the name, but if you are a student, if you apply to GitHub student pack, you get free credits for that to try and deploy on the cloud. Now, I so for rolling update, obviously we need to make some update to our website, right? Let me just show you my website. So this is my website, index.html, right? It's running on 3 nodes right now, 3 clusters, or sorry, 3 pods right now. Localhost 30,000. Oops, not 8080. This is my current website. Hello Global Hack Week. This server running on Kubernetes. Don't forget to check in. So if I click on check in, what happens? Whoops, we are on part 1. That's not the check-in we want. On that note, please check in for day 3. I'll just drop the link in the chat. But okay, so for check-in for day 3, I think it's just part 3. Is it? Yep. Oh, it's not. I'm going to give that. So I say this is not the website. We want to update this. Okay, from my side as a developer, I update this. What I do, okay, that's a lot of jargon. Let's clean this up. Put this here. Hello, this is server. Don't forget to check in. Let's make this to check in. How do I check in? I go to schedule. I go copy this link and I paste this. So I made some changes here. There you go. Let's say for day 3, and let me also add a new line. We just did a rolling update. Save. Oops. If I save it and refresh that, nothing's gonna happen. Nothing is gonna happen. Why? Because I just made change to my file and my cluster is running. The pod that is running, the container that is running is on Docker image, which I created on day 1. So now I have to again create a new image of this, the image of the updated file. How do I do that? Oops. If you remember, let's use the bottom one that is wider. Let's close this. Docker images, if I go, is version 1.0. I'm using 1.0. I'm going to create 1.1. I already created this because if there's any internet issues, but I'm going to create it again. Let's see if it works. Docker build -t, which stands for the tag that I'm about to give. That is my username, followed by the file name, version 1.1. Or let's call it 1.2 because this is different from 1.1. Let's call it 1.2. Is that fine? What I want to build image, everything in this folder, that is dot. Let's hit enter. It's not gonna work because I realized my hotel Wi-Fi for some funny reason does not open Docker desktop, Docker hub, which is very weird. I don't know why. Like, I'm disappointed. Why hotel would hate Docker? And that is why I already created image before this workshop. So yeah, for some weird reason, I cannot access the Docker hub. And to create image, you need to access the Docker hub because I'm using the latest node version, which is there on the Docker hub. I cannot create this. So I already created that, the version 1.1, which had a bit different changes. I think it just said we did a rolling update. So I created that version 1.1 2 hours ago. Let me show you without just the container, not the deployment. Docker, how do you run just the container, single container? Docker run, expose the port, external port is 8080, internal port is 8080. The image name is ashwini.exe/gsw. Version number is 1.1. So we just saw 1.0. This is 1.1. See, it says we did a rolling update. This is the Kubernetes version. This is the Docker updated version. Now I have containerized it. It's an image. Image is ready. I want to run this image or give this image to the Kubernetes cluster without letting my server go down. So it should smoothly update all the pods without anyone letting know. Oh my god, not again. Oh no. I'm so sorry. When did I lose you? What was the last thing that you lose me on? How did that happen? What was the last thing that you lost? Just let me know. Chaos, absolutely. Yes. What is a technical workshop without chaos? There's no technical workshop without chaos. So just let me know, what did I lose you on? I think I have to containerize it, right? Yeah, I think I did not make any changes. So let's see. What I meant to say is I have made changes to my website now, and I want this change to show on my pods one by one without anyone like observing that my website is down. So suddenly they see the update. Like it's very smooth. They don't even realize when it updated. I made some change. I containerize it using this command. Oops, I have to stop my container. Docker desktop, help me. 1.1, where is it? There you go. Stop this. So I have 1.0 and 1.1 has the change of this one new line. We just did a rolling update. And how do I build this? There's a command called docker build. You can see my screen, right? Yes, you can see my screen. Awesome. Docker build the following tags: h1exe/gsw version 1.1. Everything in this folder should be containerized. I did that, and this won't work because my Wi-Fi is blocking Docker Hub. So I already created that container image for you. That image for you is right here. If you can see 1.1 on the top. Docker images I prefer CLI, so I can see the image here too. It's right here. This thing has some updates. Now I want to smoothly slide this into my deployment YAML or Kubernetes cluster. So no one like it just gets updated without any destruction and stuff like that. To do that, let's do some. Let me share my screen properly now and bring this up, not to forget. Done. Awesome. So that was the recap. So sorry that happened again. StreamYard should have a feature that will automatically puts it up. But that's fine. Okay, I have made a new image now. Now I want to slide this image here, but if I slide this into my deployment.yaml, what it's going to do is going to turn off all the pods and then turn the new ones again. And that is going to have a lot of downtime if there are like 10 pods, 100 pods. It's going to turn them all off. And you saw how much time it takes to terminate the pods. That I don't want that. It's going to like be terminated for 10 minutes. And then it's going to start new pods. Not a good idea. Instead, I'm going to add some new instructions. Instructions are for deployment. So it goes under this spec, the specification of the deployment of the pods. All right. So let's see, we have done till here. So here is where the pod starts, right? So before this pod, we don't have anything else. So this is where the line, the differentiation between deployment and this is the pod instructions and container instructions. So here, before the pod instruction starts, I'll give some extra instructions before we go ahead. What are those? First, minimum ready of seconds should be 5. Or let's make it let's make it 10. Yeah, let's make it 10. What I'm saying is, before you make an update or before you make any change to any pod, the interval before you do that should be 10. So if there are 3 pods, you update the first pod, take a break of 10 seconds, and then update the second pod, then a break of 10 seconds. So before you are ready to update the second pod or the next pod, wait for a minimum of 10 seconds. Follow this strategy. So these are again from documentation. I'm not writing on my own. If I just go to Kubernetes and write rolling update, I'll just see this template, but it's a bit more elaborated in that. So I'm just putting a boiled down version. So what I'm doing is CI/CD pipeline for your updated task. Yes, it is continuous delivery in this case, and kind of like how GitHub Actions work. That is correct. Without anyone knowing. So that is exactly what I'm doing. But I have a bit more control here. So I tell what to do. Now I'm going to tell a strategy. The strategy type is called rolling update, Pascal case for values. The keys are camel case. Now rolling update, camel case, has some properties. First, called max surge should be 1. You know what is surge? The term surge, when we call it a power surge, like there's more power than there should be. Max surge means when you're updating, the maximum pods you can have, like more than required pods, should be 1. That means you can have additional of 1 pods if required. You can surge by 1 in this special scenario called update. Only when you're updating, you can have, instead of 3, it will have 4 pods when it's updating. Why? I'll tell you. Max unavailable should be 0. That means while you're doing this update, no pod should be 0. Like 0 pod should be unavailable. My desired state is 3. There should always be 3 available, no matter what. If I don't put this line, max surge 1, let's just say I just don't put this line and my availability is, while you're updating, there should be no gap. All pods should be updated. How is it possible? If it's updating first pod, there will be 2 pods available. My desired state was 3 in the replicas. And I just said at the same time that max unavailable should be 0. There should be no unavailability. But there is 1 pod unavailable. That means I'm not meeting a criteria. It's a conflict. That's why I give that special condition. You can have 1 extra pod. Let me zoom in so you can see my hand more clearly. Hey Dheeraj, how is it going? We are just explaining how rolling update works. How it works is, I have 3 pods running, 3 instances. I told that there should be 0 unavailability. My desired state is every time my pod, there should be 3 pods always available, no matter what the case. Even if you're updating, there should be 3 available. If you're updating, 1 has to go down. 1 has to go down and then a new one comes up. While that 1 is down, that's why I'm giving my Kubernetes to open a special pod, the surge pod, the extra 1 pod. That's why at a time you can have 4 pods available. So if 1 goes down for update, the other 1 is there, and there's always the desired state, that is 3 pods. Then this one is updated, the next one goes down. And then this one is updated and the next one goes down. So there's always 3 pods running and 1 is updating. That is the power of having extra pods. That is the max surge pods. I can make it 2. There'll be 2 available. I'm just putting it 1. So when I do get pods, while updating, there will be 4 pods. And after the update is done, it will delete the extra pod. Unavailable 0. I want smooth update. So no pod should go down, no extra pod, no. So if there are 3, there should always be 3. If I put it 1, it will bring 1 pod down, and it is okay to put like 3 active running pods. I don't want that. This is not the end. There are some more instructions. Oh no, wait, I guess that's it. Yeah, is that it? Template, yeah, list all good. That's it. How many lines? 1, 2, 3, 4, 5 lines, 6 lines extra to tell how a rolling update works. And that too, I'm telling it to the deployment. I'm telling it to deployment. So deployment will look and make sure that when it gets the instruction to update, it will using this method. Now let's do kubectl get pods, 3 pods running, put it on watch. On the right hand side, I'll do the updates or whatever I want. kubectl apply -f deploy.yaml has been configured, but nothing happened below. Why? Nothing happened. I don't know why. Can you tell me now? Hi Pradimna, how's it going? If you missed out, we have a recording, we have all the resources on my GitHub. Let me just drop it for you all. Everything is there for the past streams, but we're just talking about I'm about to show you how rolling update works. You remember how Instagram got the Reels feature, or how WhatsApp got the UPI feature without you even knowing, without you even updating. It got on your phone and in your friend's phone. How that rolling update works continuously. So we are doing that. Yes, this is GitOps pipeline stuff. Dheeraj asks, what is a pod? Pod is an instance. Like how your Node.js server works, just think of pod as an instance. That pod is running my application. In this case, it's a Node.js website, HTML website, uh, serving on Node.js, which says hello GSW. Pod is an instance. That's it. That's all you need to remember. That pod is the one that is running my application. So I have 3 pods. That means there are 3 different servers running. So in case one goes down, the other one takes up and stuff like that. Now, what I'm going to do is I'm going to share all of my screen. Pod, you can say as a system itself, yes. So to get into detail, pod is just a wrapper of container. You know what? If you at any day one, a Docker container, a container, has everything to run their application without the need of an OS. So it runs on any operating system. It has everything that you want. In system, yeah, you can call it a system. Not exactly, but it has everything inside of it. So if that makes you understand it, that's totally fine. That's okay. Let me open my local host 30,000 where my pod is running. Hello GSW, this server is running on Kubernetes. Don't forget to check in. Awesome. Remember, I made some changes to my website. Let me split my screen. Oops. Localhost 30,000, where are you? Split my screen. Yeah, this is a bit ugly, but we'll manage. No, we can't manage. Let's just do this. Yeah. Oops. Okay. At the bottom, I have my the status of my pods. On the top, I'm going to give my command. On the left, I should see my updates. All right. So nothing updated. Why? Because I forgot to change the image. So I'm using 1.0 here. I want to change it to 1.1. The moment I change it to 1.1 and apply it, don't forget to apply. When I change it to 1.1, it should update all my pods one by one with the gap of 10 seconds. So I give gap of 10 seconds. I can increase it if you want. Gap of 10 seconds. Do you have any questions? Am I running on Minikube? I'm running on Docker desktop. This is the easiest way you can run Kubernetes. I can run Minikube. It's a bit slow and heavy. I use Kind, which is nice, but Docker desktop has everything, and it is just easy for everyone to follow. Awesome. On the left, my old website version 1.0. On the right, I just updated to 1.1. I'm about to apply this. kubectl apply -f deploy.yaml drum rolls, enter. Okay, one container created. Let's count to 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. Another one started. Again, count to 10. Right? If I update on the left, nothing changes. One of the pod is serving my local host. And I don't know. I'm constantly refreshing on the left. Okay. And suddenly I'll see the change. Okay. So it's rolling one by one. Imagine like it's rolling on the devices. So it's rolling, updating slowly. And I'm constantly refreshing on the left. And every 10 seconds, it's updating the pod. It should quickly say that this is a rolling update on the left. Hopefully, I'm constantly refreshing on the left every second. Every 10 seconds, it's updating a new pod on the right hand side. You can see at the bottom. Let's see, drum rolls. Is it working? Are we done with 3? Look at it, terminating old ones. Oh, we did a rolling update on the left. There you go. You can see on the left. Without my website going down, it went from previous one to the new one. I did not even realize it. Even I was shocked. Like that happened pretty quickly. So if I do kubectl get pod now on the top, I have 3 new pods. All 3 are running the new version, and that's it. What questions do I have here? I just navigated to your website. Did you made it? This one? Yeah, I just made it on day one. This is a bare bones website. You mean by this website? Yes. This is not even a website. It's just a plain HTML website. So you saw how that rolling update went, right? It went from nothing to we did a rolling update. Now let's roll it back. Let's say we made a mistake. I made it to deployment. Let's just roll it back quickly. Like do you remember any feature that Instagram rolled and roll it back? Just let me know. Any feature that you feel like was there and it was not, like you just pulled it back, anything like that. So if it's there, that's how they roll back. That's no, the MLH one. No. You mean the ghw.mlh.io? That is created by the amazing, beautiful MLS team. That is not created by me. Cool. Now let's roll it back. I'm going to go back to version 1.0. All right. So kubectl apply. All I have to do is apply. All right. On the bottom, it will slowly every 10 seconds. Or let's make it a bit more challenging. Let's make it 5 seconds. So I had to change the deployment file, not the pod file. Every 5 seconds, let's make it every 5 seconds, it will slowly update. Well, not slow, it's pretty fast. Cool, no question so far. I'm going to constantly refresh on the back. It should remove this line as I refresh it. All right, and go. So I'm going to constantly refreshing it. You can see at the bottom, first container is created. I'm refreshing it every 5 seconds. Second container is created. And then third container is created. But I'm running on old containers, so it will terminate the old containers. So first, the old containers are terminated, the new created terminal containers will take up the port, this exposed port. So it's terminating the first old container, which was version 1.1. I'm rolling back, constantly pressing F5 like crazy. Second terminal is down. It's terminating. The terminating part takes, oh, and it's gone on the left. You can see without any downtime, zero downtime. This is interesting. I just used to think it automatically updates on phone because of React Native stuff. I'm not sure how React Native. I mean, it is hot reload. I don't know the exact technology used in hot reload, but this is exactly how rolling update works. So if you've heard this word a lot, like it will be rolled out to your devices. That means it's gonna come smoothly without you even realizing. That's how it works. That's why it takes time. That's why it's apart from geographical factors. It's not about like, my friend got it early and you wondering, is it the configuration or what kind of phone do you have or where you are. So it's just part of Kubernetes. So it takes time to come to your devices. Automate update task, you are hyping up interest on Kubernetes. Yes, that is the hype of Kubernetes. Absolutely. I'm so glad that you're hyped. Okay, wait, did my screen go off? Yes, it did. There you go. Awesome. So that was it. Like, I just rolled it. I'm gonna keep it on 1.1. I like it 1.1. I just do this, apply, and relax. It does the work for me. I'm gonna sip some water. I'm gonna sleep, and it's gonna update every device that it is ever deployed to. Now this is on my system. So if it's on a cloud, if all of you are watching my website, all of you are using my product, and there's something wrong, or say I want to update something, I don't have to take down my application. You can still enjoy it. And all I have to do is change features, containerize it, push the container to my Kubernetes configuration, just tell it like, okay, this is the change, do it slowly. People should not find that when it's updated, and it will slowly update it to your phones, the feature. And that's why it works. Now, another reason it works so well is because of the microservices. So this is not a monolithic application. The client is separate, the backend is separate. I just changed the client in my container, so it did not affect the backend, the node. Similarly, if my application is a bit more complex, I want to change the database, I want to update it from maybe SQL to NoSQL and stuff like that. You won't realize it Your client side will work just fine. If I created a messaging app, I want to add a new feature of calling, your messaging will still work. I will just add that new feature without you even realizing, without changing, without interrupting that original feature. That is the beauty of using Kubernetes. Now, it's not used so often in your personal project. It does not make sense. But in enterprise, it is used everywhere. If you just go to kubernetes.io, uh, click on this case studies, tons of products that we use it. Booking.com, Adidas. What do we have? Bose, Capital One, Huawei, IBM. They all use it internally. Nokia. Kubernetes is free. The hosting, the cloud, the hosting costs, but all of the Kubernetes technology is free. Spotify uses it. They use it internally. The new features in Spotify that we are getting it now, you can share with your friends and you can create blends and stuff. You can now in India, this is a great example. So the canvas we could see the video of the music was for a long time in the States. It was in the UK and the US and probably in some other countries, but not in India. And a couple of months ago, it's launched in India. We did not even realize it. I don't remember updating my Spotify app. I have my updates off, and still it comes. It came in even previous versions too. It just came automatically, and couple of phones, slowly in phones. That's a great example of rolling an update. Spotify app, great example. Last year's rap was decent, but this year's rap is even better. I wonder, is there even need of updates? There always is a need of update. So if there is a breaking change, when we are moving from version 1.2 to 2.0, which requires you to change files on system, that is where update comes in. There's a very nice story that I read when I was in like school. So back then, Play Store, there was no Kubernetes. Like there was Kubernetes, but it was not being used that wide, and there was no rolling update system. So if there was a game like Asphalt, which is like 700 MB back, huge for us, you had to re-download the whole game. You had to re-download the whole app to update it. And then Google announced a new algorithm called the Delta algorithm, which replaces the chunk of code where the update is needed. That also inspired like Kubernetes, where you just also like how GitHub works. So when you push an update, you don't push the whole files, you just push the difference. Similarly, in rolling updates, like you just push the changes. So you still need updates for major changes, but it's getting more and more prevalent. Like you can see bigger and bigger changes are coming without updating our apps. In fact, if I reinstall Instagram on my phone, it just goes back to the previous version. And then suddenly after a couple of weeks, it changes the UI just changes for some reason. And that has to do with rolling updates too. This is how updates are pushed from testing state to production state. Yes. In a lot of enterprises, yes. Not every, but most, yes. Spotify app, that's correct. Hi Karuna, how's it going? We are on time mostly. We still have a couple of minutes. I'd be happy to answer your questions or just hang around, talk more about cloud stuff. Or if you want me to play with my cluster, just let me know. Or if you want to talk about your cluster, I would be happy for you to have you on the stream. Let me know what you want to do. But yeah, this is like very interesting stuff. I was so overwhelmed with the Kubernetes because the documentation is so huge. Don't know where to start. Need to learn Docker. Need to learn containerization. Need to learn Linux. And in the need to learn, I just never started. So yeah, now we are there. Like we have 3 parts, which just covers basically what Kubernetes can do, and just enough for us to like start somewhere. Just start somewhere. A lot of people just get lost, and it's okay. We're always there to help. Yep. So far, so good. Uh, I could have a couple of examples for you. Oh, wait. So you have made this far. Okay, I'll save it for later. But I have pretty nice homework which I would like to play with myself. Only any resources that I would recommend? For sure. Most of the resources in the GitHub at the bottom. If you just scroll down, let me the nice person and share my screen and show you how. Beginner resources I have mentioned at the bottom. These are couple of which should be enough for you to go through to get basic idea. I'll add more resources here. These are for day 1 and 2. Let me add for day 3 here. I personally believe documentation is the best resource. If I just go to kubernetes.io, on the top is documentation, the best. I don't have to go from getting started to end to understand it. No. I want to learn how to deploy, search, deploy, and search. Look for the first 3 links. That's how I roll. And it works absolutely fine. You don't need to follow a very linear path. If you feel like learning by doing, take a look, try it, fail, come back, try it. That works really good. That's totally okay. And there's always community to help you out. So documentation is my favorite, but you can follow blogs. There are great YouTube channels, Tech with Nana, Kunal's stream, and there are a couple of great content out there. Feel free to go through all of that, but documentation anytime is my first preference. But your preference can be different. So there are a lot of resources. I will make sure to add that here too. I'm not a pro. Trust me, I learned so much while doing this. I strongly believe in learning by doing, and it really works. So if you want to feel like you want to be better at Kubernetes, you know what? Just feel free to take a stream. Like go to Discord and ask, hey, let's do like this live stream study session where let's create our own Kubernetes cluster and see if you can mock or teach someone how it works. You'll end up learning a lot. So I learned a lot. I learned like what is a deployment controller. I learned that you have to give some limited resources. This I learned like today, that without mentioning the processes, it could actually be harmful for my CPU because it can take, if I put 10, so let me just see if this works. I'm curious to know now. Oh, wait, monitor. So let me open my task manager. Oops. This is my task manager. I have 8.9 GB in use and CPU is going pretty fair so far. So let me change my deployment and replicas to 10. All right, let's see if this bumps up my memory and CPU. So kubectl apply should create 10 replicas, and I'm going to keep an eye on my memory and CPU. Slowly putting up. It's 8.8. Okay, the percentage is rising and falling. Not so far. It's actually falling. This is weird. Okay, it's deleting pods, so that makes sense. R kubectl get pods. Oh, wow, I have 10 pods running. Not a big change. So I guess 10 is not enough. If I get 100 pods, maybe that will definitely put a strain on my CPU. Should not do that. But I have 10 pods running now. And that's what I learned today. That if you have to be careful with how much memory you hear. I also learned like my hotel Wi-Fi does not allow Docker Hub, which is weird. Are we getting a Blahaj badge? If you, so if you stayed till the end, or if you joined till the end, I think that's fine. All of you on this amazing Blahaj badge. I called it Blahaj Netties. I made it for you all. Let me just copy this link and paste it here. So go ahead and click on this and you all earn this beautiful Blahaj Netties badge for you to flex. Go flex in the Discord server that you completed the Kubernetes cluster workshop. You deployed on your own, maybe not, maybe you'll try. But if you don't know what is a Blahaj, it's a very soft plushie. Everyone should have one. It's great. Awesome. That said, we are near the end of the stream. So good so far. I see quite the engagement, which is great. I don't see any questions, which means either you learned everything or either you understood nothing. And it is, both are fine, honestly. If you understood everything, good. If you're not, try again. Resources are there. Don't give up. It took me like months to even get started. So not just because I could not understand, because I was trying to do it alone. So do it in teams. When you do it together, it's so much fun. You have the resources, you have help Swag, thanks for reminding me. Schedule, definitely go ahead and check in. If you check in for, I guess there is a certain number of workshop, you do get customized MLH Global Hack Week December stickers shipped to you. Check it to get those points for your guild and for yourself. It is indeed cool stuff. I'm going to like containerize and put everything on Kubernetes. Like my own portfolio should be running on Kubernetes. How cool is that? Ooh, that's a nice idea. I said that out loud. It's free to take, but I'll do that. Awesome. Um, that said, we are near the end of our stream. Thank you so much for joining us. Hope get going. I'm proud of you all sticking here and surviving so far. You all deserve that badge. Uh, yeah, let me know if how do you liked it. Do you want it in the future global hack weeks, or do you want to try something new? Hello. Awesome. We'll see you around. Enjoy the global hack week, and I'll see you in the next one. Bye.